Okay, hello students, and what we're going to do today is solve. When we solve expressions algebraically or through substitution, what we're going to do is just substitute the value of one formula or one expression into the other equation. So if I have a look here, I've got two equations, y equals 2x plus 3 and 3x take y equals -1. So what you can see here is that I've got a y value and I've got a y value over here. So what I can do is just substitute this 2x plus 3 into this part of the other equation. And so what it's going to do is going to look like this. So we've got the 3x, take away the 2x plus the 3 to equal -1. And so that should be now 3x take 2x plus 3 should equal -1. And so x plus 3 should equal -1 because 3x take 2x is just x. So we can just solve that to say x equals 2. We can then just solve the value. So now that we have the x value here, x equals 2, we can solve for the y value just using the simpler equation. So y equals 2x plus 3. So we're just going to say y equals 2 times 2 plus 3. And that should give us the value of 7. Now we do need to check our work. So does 3 times x, which is 2, take 7, which is y value, equal -1? And yes, it does. So the left-hand side equals the right-hand side. And we just give a little tick when we're checking. And likewise, into the other equation, does 7 equal 2 times 2 plus 3? And yes, it does. So let's have a look at another another example here of two expressions or equations. So y equals 3x, take 14, and -2y, take 7 equal x. So this time we can just substitute in one for the other. And so we can see that I'm going to substitute, in this case, my y value is given over here. So I'm just going to replace that into this other equation. So that expression into that equation. So -2 times 3x and -2 times -14 takes 7 equal x. So we're saying -6x plus 28 because -2 times -14 is 28, and then we take 7 equal x. We can simplify that. So 21 equals 7x, and therefore x should equal 3. Then we just substitute in that x value into a simpler equation. So 3 times 3, or 3x, take 14 equals y. And so y should equal what? 9 take 14, which is -9. To do our check, then we just substitute in this case is -2 times -5 take 7, and that should equal 3. Yeah, -2 times -5 is 10, take 7 equals 3. Now we can also start to use this in real life. So if we have a look at Celsius and Fahrenheit, so they're two temperature scales that we're used to. Often when you're cooking, for example, you will see that there's a Fahrenheit scale on the oven. So if we have a look here, we've got the formula for the temperature conversion. We want to determine the formula. Given that the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit, and the boiling point is 100 degrees Celsius or 212 Fahrenheit. So we can create this formula that Fahrenheit equals the Celsius temperature multiplied by the slope of the line, and B is going to be the intercept of the line. So what we can say is that the freezing point is 32 Fahrenheit, and the Celsius is 0. So we can say that 32 equals 0 times the slope of the line, or 0 Celsius times slope of the line, plus that 32, or plus B, I should say. And then we can say that the boiling point is 212 Fahrenheit or 100 Celsius. So we can rearrange that into an equation that looks like this. 212 equals 100 Celsius times a given slope of the line plus that B function. So we can also then substitute in Let's just have a look what we're doing up here first. So 32 equals 0m plus b. Yep, that's what we've got there. And then we've got 212 take 100m equals b. So we've got a b value in which we can substitute in. So 32 equals b. Well, that makes sense. 32 equals 0m plus b. So that's true for that half. And then 212 take 100m equals b. So we can say that 32 equals 212 take 100m, and 32 take 212 equals negative 100m, and therefore negative 180 over negative 100 should give our m value, which is 9/5. So remember, 180 divided by 100, well, we can simplify that. 2 times 9 goes into 18, so 2 times 90 must go into 180, and 100 divided by that should be 5 as well. So we can have our formula that the Fahrenheit equals 9/5 of a degree of Celsius plus 32. So we've got a formula to convert there. Now we can also display this on a graph. And we can note our y-intercept. Here's our y-axis is plus 32. And we've also got a simultaneous solution here, is where these two lines meet at negative 40. Now, personally, I find this method the most easy to understand when solving simultaneous equations, and it's through the graphic method. So what we're going to do is find these two expressions, and we're going to graph them onto a line. And what we're going to do is we're going to find 2 points, so 2 sets of coordinates for each line, and then just join them up on a graph and then see where they cross over. So if we have a look at our first expression, we've got y equals 2x plus 3. So what we're going to do first of all is just substitute any number in to the equation for x to see what the y will be. And so the first time we will do it, let's make x equals 0, because that's just going to be nice and easy, and it'll be 0 on the x-axis then. So we've got y equals 2 times 0 plus 3. Well, that's going to be y is going to equal positive 3 when it's 0 on the x-axis. So we have our first set of coordinates of 0, 3. Then let's just choose another small easy number like x equal 2. And so what we'll just say is y equals 2 times 2 plus 3. So when x equals 2, y equals 7. So we've got 2 points to put onto a graph, and then we can just use a ruler to draw a line through it. Now let's look at the other equation. We're going to make x equals 0 again. So this time it's 3 times 0 take y equals 5. But we're going to rearrange this first of all to isolate the variable y on one side of the equation. So we're just swapping the negative y and the negative 5 over. They become positives. So we say that 3x plus 5 equals y. So let's substitute 0 in now. So we're saying that y equals 3 times 0 plus 5. So when x equals 0, y equals 5. Then we're just going to find a smaller number like x equal 2, and then just substitute that into the equation. So 3x plus 5 equals y. So we just say, well, 3 times 2 is 6 plus 5. Well, when x equals 2, y must equal 11, is it? Or equal 5? What have I done there? That should be 11. So then we just graph those onto the those two lines onto the equation. So we've got 2 sets of equations. So let's look at our first one, 0 and 3. So when x equals 0, y equals 3. So that's our 0, 3 coordinate. And then we've got 2, 7. So that's our 2, 7. Then you just draw dots on a graph and then get a ruler and draw a straight line through them. Then the next step is to look at the next line, and so we've got 0, 5, so that's 0, 5 there, and 2, 11, and join those 2 dots up with a straight line. Then we just need to identify that point of intersection. Now that point of intersection is where those two lines cross over. So that's -2 on the x-axis and -1 on the y-axis. So you just interpret the answer. The solution is when x equals -2 and y equals -1. Now we just do need to check that expression. So what we do is you say, does the left-hand side equal the right-hand side? When we substitute in x equal -2 and y equal -1. And so you can see that, yes, it does through checking. Now you can also notice that when these two values are the same here for the two expressions, that will be the same coordinates as here. So -1, -1 there for both of those when x is the same as -2. So if you draw this up in a data table, for example, in Excel or by hand, you'll notice that that is also a simultaneous solution when those two numbers match up. Now, when we use the elimination method, we're going to combine the two equations to cancel one value. And then we're going to simplify and solve for x, and then we'll substitute the x value and solve for y. So let's have a look. We've got two equations here. 2x plus 3y equals 15. And x take 3y equals 3. So what we can do is just combine those two expressions together. So we've got 2x plus x over here plus 3y equals, take 3y equals, what's on the right hand side? 15 and 3. So we've just combined both of those equations, and then we can simplify. Well, we've got 2x plus x, which is 3x. Now 3y, take 3y is 0, and then 15 plus 3 is 18. So we know that 3x is 18, therefore 18 divided by 3 is 6, and so x will equal 6. Now we know the value of x, we just substitute and solve for y. So we can just say, well, what's our easy equation? We've got x take 3y equals 3, so 6 takes 3y is 3. Therefore, 3 is the same as saying 3y. Therefore, y equals 1. Then we just substitute by putting into a simple equation and checking if the left-hand side equals the right-hand side, and it does. Now, if we have a look at some worded examples, we're just going to be able to get some everyday problems and put them into a mathematical expression. So we've got 2 fish and a serving of chips costing $20, but 5 fish and 4 servings of chips is $56. So we want to create equations to find the value of a serving of chips. So first of all, let's define the variables. Well, let's make f equal fish and c equals chips. Then we're going to create the equations. So 2f, so 2 fish and 1 chips equals $20, but 5 fish and 4 chips equals $56. Therefore, we can say that the chips equals $20 take away 2 lots of fish. And then we can isolate that variable and put it into the simpler equation. So we're saying, well, 5 fish plus 4 chips, but 4 chips is really saying 4 lots of this here. 20 take 2f, so we've just substituted that into the other equation, equals $56. Now we can just collect like terms and simplify. So in this case, we've got 5 fish, take away 8 fish. Well, 4 times 2f is 8 fish, equals 56, take away 80. So 4 times 20 is 80, but there's a plus. So to get it on the other side of the equation, we've got a minus. So 5f take 8f equals 56, take 80. So -3f equals -24. So we just divide both sides by -3 to find that fish equals, what, $8. Now we can just substitute into an equation to find the value of chips. So we know that 2 times fish, or 2 times 8, equals 16, plus chips equals 20. So the chips is 20 take 16, which is $4. Just interpret that answer to say a serving of chips is $4. Okay, hello students. Today we're going to be looking at the break-even point and how to solve this using a simultaneous equation, setting it up in Microsoft Excel. So we've got this problem here. It says Year 12 students planning a school push dance at the cost of the hall and the band is what, $500, and then there's going to be another $6 per person for food hire, for food and drink. Now, up to 200 students may attend, and the ticket price is going to be $15, and we want to just calculate what is the break-even point. So what we're going to do is just to start to set up our table, and we want to create two lines on the graph, and that's the income and the costs. So if we have a look here, we've got 0 to 200 students. So I'm just going to go 0, 10, 20. And then I'm just going to take that pattern out to 200. So 200 is here. Now that's stretched out a bit, so I'm just going to shrink them in a bit. So that's a little bit smaller. I could have done that a little bit more because that's still not fitting on the screen. So let's try that. Hopefully that will fit on all right. That might be too cozy, we'll see. Now, what do we say? The cost was $500 and then another $6 per student. So what we want to do is now create our cost line. So we've got our cost was $500 plus $6 times the number of students. Now we've created the number of students as our top row in our Excel table here. So my formula for cost is just 500 plus 6 times the number of students. And the number of students is going to be that top column there. And so that for 0 students, well, that makes sense. It's going to be $500. Now, once I've set that formula up, I can just left click and drag over. And I can also, let's just make that into dollars format. Okay, and that's a little bit too small. So we'll just drag that out. Oh, that's just not nice. I'll just take it off then. And now let's have a look at our income. Our income was $15 per student. So I was just going to go equals 15 multiplied by, where's my multiplier? There it is, times that number of students. And no income coming in for 0 students. Yeah, have a look there. I wonder if I can change that. Not easily. Not unless I go general number up there. Okay. And let's continue now. I've got my formula there, so I'm just going to left click and drag. Need to drag that a little bit down and over here to 200. Now don't worry too much about those hashtags just yet. What I can do is actually reduce the number of decimals. So there we go. And that makes it all fit in there nicely. And now we want to graph this. So I'm going to select all of this and select that table. Now we just want to insert, it's going to be an XY scatter graph with lines, and that's probably going to be a bit nicer. Let's have a look at what we're saying. We're saying that the break-even point is the point at which the income and the expenses are equal. So that's our break-even point. So if I look here, all this is profit, all here is loss. So I start to break even at around 60 students. Now if I have a look at this on the table, yeah, okay, so my cost here is 860 and my income is 900. So at 60 students, I'm making a profit of $40. It's been a big lesson today, folks. First of all, we've noticed that simultaneous equations are when the x value and the y value are the same for 2 different equations. We've solved them 3 different ways: graphically, substitution, and elimination method. We've noticed that we can use this, for example, with a break-even point where cost and revenue are the same, and we've done it with Celsius and Fahrenheit as well. Finally, can I get you to exercise your mastery of the concept by working on the problems below?